As we move into the new millennium, great efforts and accomplishments are being made in the field of renewable energy. During the past decade in the United States, solar installations have grown 17-fold, and wind energy makes up more than 5% of our nation's energy usage. That being said, there is still much more work to be done. The Trump administration has changed the political atmosphere and made it easier for big businesses to do whatever they want, and regulatory authorities are being disempowered. This doesn't have to be a bad thing. Now is a perfect window of time for pioneers to embark on new endeavors. As the inevitable transfer from gasoline and diesel-fueled vehicles to the electric car takes place, great changes in the nation's energy production and storage will need to occur. How exactly this will pan out is uncertain, and we've got an idea we'd like to bring to the table.
But I want to give you another duty of water which will relieve your mind greatly. Have a little stream trickle along here. You can lead it out a bit and then drop it. You have a sort of large funnel, and inside the funnel you have a solid cone of aluminium all drilled out with holes. And then you put the water down this funnel, and away it goes down here. All those little straws are sucking air desperately, and that means there are thousands of little bubbles entering this water stream that were not there up there. Now what's the effect of that? It's got 200 feet of water above it, didn't it? It got tiny, didn't it? Yeah, highly pressurised. Did it get hot like it does in your bike pump? No. Why didn't it? It's totally surrounded by water, and so the water very rapidly removes any heat of compression. So this air is very valuable. It's called isothermically compressed. Now isothermically compressed air, it's very, very clean. What about electricity? Very easily converts to electricity because no problem getting good high speeds on generators. Some of these machines were 4,600 horsepower. So they're gigantic machines. Yes, you'll love the name. It's called a Tromp. You know that word, don't you? You've been to many an art gallery, and there they are. Tromp do you, aren't they? Smack in the eye. It's a shock to the system. Or art is often that. Well, this just simply is Tromp. You get any damn statue to weak blood if you've got a good Tromp. You can have quite a gentle stream. You're only going to take it up 10 feet and drop it down this shaft. And when it comes back up again and goes on, you can drop it down again somewhere else. So time after time after time after time. Trompy, trompy, trompy. And one thing everybody knows who grew up in the days of Tromps is that there's a lot of trout in these streams because you never get every bubble out. And so you have very well oxygenated water going from Tromp to Tromp. If you use fairly clean water, you end up with extraordinarily clean water. So it's very beneficial. It's a beautiful system, no moving parts. You know, in and out fast, no one gets hurt. And you can't forget the name, can you? Tromp.
This is a drawing showing the construction schematics of the Ragged Chute air plant built on the Montreal River around 1910 to supply compressed air to the numerous mines at Cobalt. At the Ragged Chutes air plant, The water flows into a large chamber 40 by 50 feet, where twin heads 16 feet in diameter with 72 14-inch diameter circular pipes in each head. The water covers these pipes at a controlled depth so that the swirling waters entering the pipes suck down large amounts of air and takes it to the bottom of the shaft 351 feet from surface. At the bottom of the shaft, the water strikes two steel-covered pillars, concrete-covered pillars, and then proceeds 1,221 feet in the horizontal tunnel, and then discharged through the exit shaft into the Montreal River. These steel-covered cones at the bottom of the shaft help to separate the air from the water, and as the water and air travel along this tunnel, it rises and comes into an air chamber or a receiver, and then rises to the top, and it will reach a pressure of 125 pounds per square inch. This air is sent to surface through a 24-inch steel pipe, and from there it is sent on into the Doomer's mines in cobalt. If the pressure rises above 125 pounds, or a little bit more, it forces this water to drop a certain amount, and then that action causes excess air and water to travel up this discharge pipe and exit into the atmosphere, which makes the blow-off that you'll see later on in the film.
On a bright sunny day, water and air is all mixed up with sunlight in the area.
I made a little model Tromp too, and this is how it works. The water and air enter up here, they go down the U, over, up the U, and then shoot out. And then this little pipe here goes down to that pocket of air, and I put this little valve on top up here. And here's a closer look at this part. Water goes in the side, air gets sucked in the top. And this is what it looks like when it's off of it. I made it out of a PVC TY, some straws, and some silicone that I got from the store. The tops of the straws are exposed to the air, and water goes in through the side right here through this flap, which is to keep this vacuum seal. And as the water falls down, it surrounds the bottom of each straw, which creates a little vacuum sucking the air in from the top. warrior. The warrior's prey. Recently, on a trip to Ottawa, I got to meet with inventor Afif Abu Raphael. Afif is the inventor of a plug which stopped the world's largest oil spill ever, and Afif remains to get credit for this work.
How did you get to know about me?
I'll tell you, because I am so interested in these Tromps, and I was just doing research on the computer, and I came across, of course, the Ragged Chutes air plant, and I found this website, and I saw your comments, and that's literally how I learned about you. Yeah, through.
You got interested.
I'm so interested. I'm wicked interested. Yeah.
So. Okay, Mr. Taylor. Well, Mr. Taylor was bright. You remember? Here in Buckingham, right here.
Yeah.
He invented his compressor.
Are you serious?
Right here. Right there.
And he was a smart guy.
What?
Well, he was smart and maybe.
Well, I took it, but nobody look
Yeah.
at the Canadian museum stuff. They don't know about the compressor. And it was
Why don't they know about it?
Nobody knows.
Why?
Stupid.
Because nobody.
They don't know what to do with it, and
Yeah.
it is the best tool to produce electricity from water and produce more. That's something. So that's another invention. We should work on it. We should work and make it work.
Being really excited about the possibility of building massive Tromps like Charles Havelock Taylor did, me and my bro went and talked with Scott Berk about a similar operation at his very own cafe.
I went to college. I was Colorado School of Mines. I have a degree in mining engineering from the Colorado School of Mines.
What did you do in Quincy?
I was the quality control engineer for a project that was being overseen by the Army Corps of Engineers. It was a flood control project, $20 million, that involved a tunnel that was about 1.5 miles long underneath the town of Quincy, connected by 2 shafts, 2 180-foot deep shafts.
Wow. So kind of like a giant U-shape.
Giant U-shape, correct. So with one end higher than the other,
Yep.
so that when water came, instead of going through downtown Quincy and flooding out all the stores, it would get channeled into the top of the shaft, go down the shaft, through the tunnel, up the other side, and dumped into the ocean. So it's a flood control.
Wow. How did you do the vertical shafts? What was the...
So the vertical shafts were all drill and blast, so manual drills and or pneumatic drills mounted on little excavators. And so basically drilling. So the first part of the shaft was through dirt, so that was just dirt dug with interlocking steel ring of plates that are driven down into the ground, and then you dig sort of the dirt from the inside of it as you drive those down. And so you do that till you hit the top of the rock, and then once you hit the rock, you drill out drill patterns, fill them full of explosives, blast, remove that, drill again, blow it up, dig, drill, explosives, dig. And so you go down in, I know what lifts we were doing, 8 foot, 10 foot increments. So every round you remove 10 foot of rock, basically blow up 10 foot of rock, and then you drill it again and do that, and you do that down until you get to 180 feet. And then you have to turn the corner 90 degrees, drive out, same method, drilling, blasting for maybe 200 or 300 feet. So you got to create enough room to set up the machine. The machines are big, right? So it takes a lot of space to set them up. And then it's dropped down piece by piece down the shaft and assembled underground. And then we fire it up and off you go. They're safe. I mean, relatively low, very low accident rates. Safety is taken very, very seriously. There's safety meetings every morning. If any of the workers have concern, they're supposed to bring them. They're supposed to let people know. So, I mean, there's a lot of precautions. There's a lot of rules involved in working underground. Federal rules. So, for tunnels, OSHA, the Occupational Safety Health, are the ones that set the rules, and they're pretty stringent. So there's a lot of things in terms of air quality, because you have to keep breathable air down there, right? So you're always there's a whole ventilation system that's going on. The strength of the rock, make sure it's not a dangerous work environment, make sure there's no buildup of dangerous gases. So there's continuous air testing that would go on down there. That was one of my jobs. I had to go down there and test the air and make sure the air is breathable, there's nothing dangerous, there's no buildup of anything explosive. Particularly you're working underneath a city. I mean, who knows what's down there, right? In terms of leaky pipes, or there's a whole infrastructure above you that could potentially impact the area. And you're working on huge pieces of equipment, and these guys are all trained. I mean, they're all skilled laborers, and so there's a lot of safety protocols involved in working around. If you drop something down a 200-foot shaft, a little thing, after 200 feet, it's going fast enough to kill somebody. So you have to be very careful working, if people are working above or people are working below. There's all sorts of protocols involved and rules and regulations involved. It's a fascinating environment, right? And it's similar to mining, just the difference being that you're mining space as opposed to a particular type of rock.
Right. Mm-hmm.
Well, so I show up in Boston. It's a union job, tunnel workers union, local 88, and they are a fairly rough group. So the first day on the job, first few days on the job, one of the union guys walks up to me, gets right in my face, and goes, "You look like a f***ing tree hugger."
Oh.
And I looked at him, I went, "Yeah, maybe." So that was my name for the rest of the job, was tree hugger. They all called me tree hugger. They were great. I ended up getting along with all the guys really well, but it was eye-opening. I was in the bottom of the shaft one day, and there's a man cage that you would get pulled up and down the shaft in. That was maybe about 3 foot by 3 foot. It's a pretty small space. So I get in the man cage with this guy, and we closed the door, and for something was going on up top, so we weren't getting pulled out. And all of a sudden he started to get really sort of twitched and clearly angry. And all of a sudden he rips the door open, and he goes stomping out of the man cage, and he turns around and he says, "I spent 2 years in a hole smaller than that in Vietnam. I just can't take it. I'm sorry." And I was just like, "Holy shit." Like, all right. And you work underground?
Right.
So he was, but this same guy, right?
Yeah.
he was what's called the bottom man. So he was in charge of everything that was going on at the bottom of the shaft, getting the crane, sort of signaling the crane up and down. So we had a swamp next to the job site. And in the spring, there was all sorts of wildflowers that would grow out there. And so first thing in the morning, he would show up and he would go out there and he'd pick these wildflowers and he'd bring them down to the bottom of the shaft and create this beautiful bouquet of flowers. And he had flower boxes down there, and he had an old window frame that leaned up against the rock. And then he'd cut these curtains, and he would do these fresh flower arrangements every morning down there. And they were the coolest things.
Wow.
They were just beautiful. I mean, the guy was like this really talented flower arranger.
That's awesome.
So, yeah, it was. So there's like these real sort of dichotomy in terms of these people and their personalities, and yeah.
Solar panels as a renewable source of energy have a relatively small to neutral impact on the environment. The raw materials needed to build the panels have to be mined or are sometimes recycled. Tromps, however, when made with concrete and steel, will last for a really long time, with little maintenance until it gets busted by an earthquake. Running a tromp also has the positive effect of dissolving oxygen into the water, which is very beneficial to the biology of the river. Tromps can be very powerful, and like they say, with great power comes great responsibility. If we're using the flow of the river today, we must do our best to make sure the river flows tomorrow.